I'm Anil Kumar, and in this video we'll discuss about system of two planes. When we have two planes, then there is a possibility that they may intersect, and there is a possibility that they may not intersect. So let's consider the two cases. One in which they don't intersect. That means they're parallel, right? So we have two planes here. This is one, and then we can draw the other one in a different ink. Say this is the other one. Now these two planes are parallel planes and they do not intersect. So if they don't intersect, we say that the system is inconsistent. They do not intersect. That means they don't have any common point, right? So that means they don't have any common point. That is what we mean when we say that the planes are parallel or they don't intersect. Now planes are normally defined with a normal. So if let's say this is the plane pi 1 and this is the plane pi 2 and their normals are n1 and n2, then you'll find that the normals are scalar multiples. So n1 is a scalar multiple of n2. Now there's one more important aspect to this. That is, let's also consider the scalar equation of the two planes. Generally, the equation is written as ax plus by plus cz plus d equals to 0. Now if their normals are scalar multiples, then d should also be a scalar multiple, right? Or not. This is what you have to consider. So that is a critical thing. So what we have here is that the two planes are parallel if and only if that the normals are scalar multiples, but this d, the constant, is not. So d is, say d1 is not equals to k times d2. That is kind of important. In case this value of constant is also a scalar multiple, in that case they are exactly the same planes. Do you understand? In that case we have a scenario where the two planes are overlapping. So in that case the two planes will be, so let me draw like this, showing you kind of overlapping planes. Okay, so these are overlapping planes. So if they are overlapping, then they intersect at all the points. In that case the system is consistent. Since they have points of intersection and plane is common, so they have all points of intersection, so infinite points, or the plane itself is same, right? So in this case n1 equals to k times n2, and this constant d is also scalar multiple. So d1 is also equals to k times d2. So the equations are kind of exactly same. For example, if one equation is a1x plus b2y, let me write b1, right? c1z plus d1 equals to 0, then the other one is k times all this equals to 0. Do you understand? So everything here is a scalar multiple of k. Then they're exactly same planes, right? Then this will be a1x plus b1y plus c1z plus d1 and k times scalar multiple. In that case they're exactly same planes. For example, if I write a plane 2x minus 3y plus z plus 4 equals to 0, and the other one as 4x minus 6y plus 2z plus 8 equals to 0, then they are same planes. On the other hand, if I write here 2x minus 3y plus z plus 4 equals to 0, and the other one as 4x minus 6y plus 2z plus not 8 but any other number, let's say 7 equals to 0, then they are parallel. Do you see that? They are not exactly same, they are parallel. So this is a very important criteria to understand, that the planes could have same scalar multiples of normals, In one case, they could be parallel without any point of intersection, and we'll call that system as inconsistent. In the other case, they may be exactly same, right? And then the system will be consistent, and they will have all points as common since the planes are exactly same. Now let's look into third scenario in which two planes intersect. How will they intersect if they intersect other than overlapping? They could only intersect in a line. So the other plane could go through this plane in a line. For example, like this. Do you see that? This plane intersects the other plane and they have a line in common. So this system is also consistent, right? Since they have a solution. And here they intersect in a line. So we can always find equation of a line for the two planes to intersect, right? That is also a set of infinite points because line is a set of infinite points, right? In this case, normals are not scalar multiples. That is very important. Normals are not scalar multiples. So if the normals are not scalar multiple, then the planes will always intersect in a line, right? So that is how the system of two planes can be seen. Now in most of the examples in which we will consider intersection of planes, we'll have few problems in which we'll say, well, one equation has this value as a k, so what value of k will make them consistent or make them inconsistent, right? So in that case, you know now, consistent means that we have a solution, that means they are exactly same. Inconsistent means they are parallel and they don't overlap. Now, in this particular case, we will like to equate the two equations and then solve for the line. So that is how you say. So normally, we'll have two equations of the form ax plus by plus cz plus d equals to 0, and the other one will be, let us say this is the first equation, and the other one will be a2x plus b2y plus c2z plus d2 equals to 0. As you see, there are a lot of parameters to find and only two equations to work with. A, B, C, all are unknowns. The point of intersection, I mean to say, right? So when we are trying to find the point of intersection, in that case, D's are known to us, these are the constants, but we don't know at which point x, y, and z values are they going to intersect, right? The constants are all known to us, capital letters. But what we're trying to find is x1, y1, z1. We are trying to find that set of points which will give us the intersection of the plane. Now we cannot really find them since there are two equations to work with, and therefore we take help of parameters. And as soon as we define our parameter, we get equation of line. Do you see that? With its direction number. So you'll always see that the planes will intersect and will have parameters to define and help us out to find the line of intersection in each and every case. So we don't really get a point of intersection when two planes are intersecting. They will always intersect in a line, right? So in such cases, when we are solving the equation, you will have to use one of the parameters. For example, z equals to t, and then define all of the terms in terms of that parameter to get the equation of the line. So that is kind of important to understand. And second part is, if you are using the matrix method, then I should say, how will the matrix look like in these two cases? In consistent case, matrix will look like, will have 0, 0, 0 equals to 0, right? That means it is, this is for the consistent. Let me go back to this. If we have a solution, then the matrix will look like the last column will be 0, 0, 0, 0, right? Here we may have some numbers. But if 0, 0, 0 equals to 0, this is always true. Since it is always true, the planes will be overlapping. But if we get a number here rather than 0, then a number will never be equal to 0, right? And these could be other numbers. In that case, a number, let's say 5, is never equal to 0. Therefore, we don't really get a solution, and we know the system is inconsistent, right? In this particular case, if you solve the matrix, then you will get 0, 0 number and some other number, right? So in that case, you can relate the two, right? And once you relate, you are able to find the solution of the matrix. So that is the case. And at times, basically, you may get 2 here. So you are able to eliminate 1 actually. So you can write 1 in terms of the other parameter. So it should be like this, in fact. So that is how you are going to get or see the solutions for your when you solve your equations for the system of planes. I hope I have covered a lot here. We'll do some examples of each kind and see what really happens and how to solve system of 2 planes. I hope that helps you. Thank you and all the best.